Hello everyone, this is Pius Rabbi, and now I'm going to discuss differential calculus. First, I'm going to show us differential notations. Second, I'm going to present the differential formula from the graph. So let's get right into it. So first, we'll talk about the differential notation as I said. And to do that, let's think of y as a function of x. So in that case, our f of x is equal to y. So finding f prime x, which is the first derivative of the function, so that's going to be the y over the x. So that is the first derivative. That is how to express first derivative. And to find second derivative, you write it this way, and this will be equal to the square y over the x squared. That's how to express second order derivative. And if you are talking about the third order derivative, that's going to be the cube y over the x cube. And if you are finding fourth order derivative, so that's going to be the fourth, d to fourth power, y over the x to the fourth. So it can continue on and on and on like that. So if you are finding the nth derivative, that's going to be f raised to power n of x, which is equal to the nth y over the x nth. So that is how to note differential calculus. So you'll be seeing this sometimes, and you'll be seeing this some other times. So when differential is expressed this way, so you are dealing with the Newton's formula. The Newton's formula. And when it is expressed this way, you are dealing with the Leibniz formula. The Leibniz formula. But they mean the same thing. They are referring to differentiation. Having discussed the differential notation, we shall turn to differential formula. And we are going to do that through this graph over here. So on the graph, we have x and y axis. And we have a line passing through 2 points. So the line passing through 2 points, let's say point A and point B. So this point over here and this point over here. So the line passing through the 2 points is known as the secant line. So a secant line is a line that passes through 2 points on a curve. And there's another line here which touches just 1 point. That is point A. So the line that is tangent or that touches point A is known as the tangent line. So we have the secant line and we have the tangent line. So we trace point A down, we have x1, which is the initial x, and the second x2, which is the final x. So if we trace point A again to y1, which is the initial y, and then trace B to y, which is y2, which is the final y. So now the first thing we are going to find is the second slope, and the second slope is denoted as MAB, that is the slope between 2 points over the range between 2 points, point A and B, so which is change in y over change in x. Change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. So the difference between x1 and x2 is change in x, and the difference between y2 and y1 is change in y. So change in y over change in x is the slope over the range between point A and B, over the interval between point A and point B. So that is the second slope. Now the second slope, which is the tangent slope, the tangent slope, which can be denoted as m tan, is equal to dy dx, and that is our differentiation. So second slope is not differentiation itself, it is tangent slope that is talking about the differentiation, right? And that, I mean dy dx, is talking about slope at a point, slope at the initial point, at the initial state. So instead of finding slope over an interval between 2 points A and B, now we are just looking at the slope at point A. Are you getting it? Meaning that we are looking for the slope as point B approaches point A. So as point B moves closer and closer to point A, x2 moves closer and closer to x1. So that is what, and the approaching process of point B to point A and x2 to x1 can be expressed as a limit. So our dy dx, which is the slope at a point, at the initial point A, is going to be the limit of y2 minus y1 over x2 minus x1 as x2 tends to x1. So as x2 moves closer and closer to x1, so the limit of the second slope is our tangent slope. So that is how we can find the slope at point A, at the initial point. So we can't just use secant slope to find slope at a point, because the difference between the same point is actually 0. So because the same point deducted from itself, that will give you 0, and 0 over 0, that will be undefined. So in order to make sense, we need to first look for the secant slope and then find the limit of that. So that is how we can get the tangent slope. So I hope we are clear on that. Now that we have known what our tangent slope is and how it is different from the secant slope, and the difference between the secant slope and the tangent slope is the limit, so we can continue with our dy dx and see if we can design this formula over here in a more acceptable or in a more standard way. So, and that is going to be dy dx equals the limit of, now y2 can be expressed as a function of x2. So instead of writing y2, we can write f x2 minus, instead of writing y1, we can write f x1. So we still have our x2 minus x1 as x2 approaches x1. So simple. Now we can still express this in a more standard form, which is going to be the limit of the function of, now our x2, the difference between x1 and x2 is change in x. So our x2 is just x1 plus change in x, because that is what moves it to become x2. So when you add change in x to x1, that will give you x2. So that will give you x2. Then minus f x1 whole over, now our x2 minus x1 at the denominator will be expressed as just change in x, because x2 minus x1 is change in x, still as so instead of saying as x2 approaches x1, so we can just say as change in x approaches 0, because as x2 moves closer and closer to x1, the difference between x2 and x1 shrinks towards 0. So it gets smaller and smaller and smaller and smaller towards 0. So that is why I put change in x tends to 0. So as x2 falls to 0, as x2 falls to x1, change in x is getting smaller and smaller to 0. So our dy dx can also be expressed as the limit of f of, so at times we just say we don't need to say x1, let's just say x, and then make the difference between x1 and x2 h minus f of x. So this is another way of expressing that formula all over h. So h represents our change in x. Now instead of change in x, we have h tends to 0. So that is our dy dx. That's our dy dx. So this formula is the general differential formula that is gotten from that graph, and it can be used to solve differential problems actually. And we are going to use it to solve some problems right away. So let's say we have, I'm looking for a space where we can, okay, let me just rub this that we can solve question. So we want to use that formula to differentiate and see if it will work. So let's say that y is equal to x squared plus 6x plus 3. So we want to find dy dx. So what is dy dx? What is dy dx? That's the question. So we can use the formula to solve the question. But to make life easy for ourselves, we can just start from the second slope, which is change in y over change in x, and that is going to be f of x plus h minus f of x. I'm not putting limit now because I'm dealing with the second slope first, so that if I can work with this, I'll just take the limit to get dy dx at the end of the day. So this is going to be, so our f of x plus h is going to be, so what we are going to do is that for the first part here, for the first part in this box here, we are just going to put x plus h everywhere we find x. So instead of x squared, we say x plus h squared plus, instead of 6x, we say 6 into x plus h, then plus 3. You get all these minus f of x, which is x squared plus 6x plus 3 itself, and that is going to be, now you want to open the inner brackets, which is x plus h raised to power 2, and to find that you can apply algebraic identity of square of a sum. So a plus b raised to power 2 is going to be a squared plus 2ab plus b squared. So meaning that x plus h squared is equal to x squared plus 2hx plus h squared. So this is what you are going to bring right to this place. So now you have x squared plus 2hx 2hx plus h squared, then plus 6x plus 6h plus 3, right? Whole of these minus x squared plus 6x plus 3. So that's how to do it. So remember, all will be divided by h. Please don't forget. All will be divided by h. Like here also will be divided by what? By h. And that is going to be equal to x2 minus x squared minus x squared, 6x minus 6x, and 3 minus 3. So that's going to leave 2hx plus h squared plus 6h over h. So now you can cut h in each term at the denominator. So you have h, cut h here, cut 1h here, cut h here. So you have 2x plus h plus 6. And that is going to be... Now, be reminded that since morning, what you have been finding is the second slope, which is change in y over change in x. Now you want to find the y, the x, which is going to be the limit of changing y over changing x, which is 2x plus h plus 6, as what? As h tends to 0. And that's going to be equal to 2x plus h, which is 0, plus 6. Now your final answer is going to be your dy dx dx is going to be equal to 2x plus 6. That's the final answer. So let's solve another question to see how that formula plays out. So another question. Let's say that y is equal to 1 over 3x squared. So how do we find this question? So first, we are looking for change in y over change in x, which is equal to f of x plus h minus f of x over over h, rather, over h. So in this case, we are going to say that our f of x plus h will be 1 over 3 into x plus h raised to power 2. The reason for that is that for the first function, you are going to put x plus h everywhere you find x. Then minus f of x itself, which is 1 over 3x raised to power 2. Y is f of x. So everything here over h, or instead of saying everything here over h, you can make life simple right from the beginning and say this is equal to 1 over h. You get, so whatever you get inside this bracket will be multiplied by 1 over h, so, and that's going to be 1 over h into. Now we'll do fraction. What's the LCM of the denominator? What is the LCM of 3x plus h squared and 3x squared? So the LCM will be 3 is common, so pick 3, and that's the only thing that's common. So whatever is left in the first, which is x plus, which is x plus h raised to power 2 and x raised to power 2. So in other words, we are going to have something like 3x raised to power 2, then x plus h raised to power 2. So that's the LCD, the LCM of the denominator. So you have 3x squared and x plus h raised to power 2. Then we combine the fraction. So we will say that the first denominator in the LCD, which is 3 and x plus h squared, so that will remain x squared minus so the second denominator, which is 3x squared, so we cut it away from the LCM of the denominator, that will remain x plus h raised to power 2. So we combine the fraction inside the brackets. So next we have 1 over h into x squared minus, so the square of a sum again, that is a plus b squared, is equal to a squared plus 2ab plus b squared. So this is going to be x squared plus 2hx plus h squared into brackets. So all over 3x squared x plus h squared. X plus h squared, and this is going to be equal to, so this cancel this, we have 1 over h into minus 2hx plus h squared over 3x squared into x plus h squared, which is equal to, so h cancel h here, cancel h here, so we have minus 2x minus h. So we are talking about this minus here. So we're just going to affect everything inside the bracket. So whole over 3x squared x plus h squared. So everything we've been finding since morning is changing y over changing x. Now the y over the x will now be equal to the limit of minus 2x minus h over 3x squared x plus h squared as h tends to 0. So the final answer on that is going to be dy dx is equal to minus 2x minus our h tends to 0 over, so here we have 3x squared into x plus h, which tends to 0 raised to power 2. So here we have minus 2x over 3x squared times x squared, because x plus 0 is x, then raised to power 2. So here we have minus 2x over 3x times x squared times x squared. Law of indices, that is x raised to power 2 plus 2, which is x raised to power 4. So this is x raised to power 4. Right? So the next thing to do here, if need be, is to express our dy dx in index form, and that's going to be minus 2 over 3. So of course this x is going to cut one x here, which is going to be x raised to power 3. That's going to be x raised to power 3. X raised to power 3. Then we can say that minus 2 over 3 x raised to power minus 3. So that is the final answer. So you can see everything that we've done over here. So we are applying the differential formula that we derived. So in the next class, I'm going to discuss this same question, these two questions that I just solved down, but I'm going to make use of the first principle to explain them. Thank you. Hi everyone, this is Pius Rabbi, and now I'm going to discuss the first principle in differential calculus. So the initial settings of first principle can be done in this manner. Let's say y is equal to x, then y plus change in y is equal to x plus change in x. Let's say y is equal to 2x, then y plus change in y is equal to 2, then you put x plus change in x. Then if y equals x squared, is it 2x squared? Then y plus changing y is equal to 2x plus changing x raised to power 2. Then if y equals 2x cubed minus 5x squared plus 5, then y plus changing y is equal to, now you are going to put x plus changing x everywhere you find x. So that's going to be 2x plus changing x raised to power 3 minus 5x plus changing x raised to power 2, then plus 5. So that is how to set your initial problem in first principle, your initial solution. So but now I'm going to solve some questions that will show the process of first principle from start to finish. So let me show the question right away. Now let's say y is equal to x squared plus 6x plus 3. So to differentiate this, we want to find the y dx. So what is it? So y is equal to x squared plus 6x plus 3. So y plus changing y is equal to x plus changing x raised to power 2 plus 6 into x plus changing x, then plus 3. Then changing y is equal to x plus changing x raised to power 2 plus 6 into x plus changing x plus 3 whole minus y. Now changing y is equal to, so we are going to open these brackets, which is going to be square of a sum, that is a squared plus 2ab plus b squared. So for x plus changing x, that's going to be x squared plus 2x changing x plus changing x squared. Then plus 6x plus 6 changing x plus 3 all in parentheses minus y. What is our y? Our y is x squared plus 6x plus 3. So now we're going to perform the polynomial operation. So our changing y is going to be equal to, let me express that better. our change in y is equal to x squared cancel x squared, because x squared minus x squared is 0. Then 6x right over here, cancel out this 6x, and this 3 cancel out this 3. So now we have 2x changing x plus changing x squared plus 6 changing x. So that's all. So now we want to find changing y over changing x, which is equal to 2x changing x plus changing x squared plus 6 changing x whole over changing x. So changing x called changing x all through the numerator. So that's going to be 2x plus changing x plus 6. So what you have been finding all the way is changing y over changing x, and the y, the x is the limit of that, the limit of 2x plus changing x plus 6 as changing x tends to 0, and that's going to be 2x plus changing x, which is 0, plus 6, which is equal to 2x plus 6. That's the final answer. So let's try the second question. Let's try the second question. So now, let's say that y is equal to 1 over 3x squared. So we want to find dy dx. What is our dy dx? So now y is equal to 1 over 3x squared. Y plus changing y is equal to 1 over 3x plus changing x raised to power 2, and changing y is equal to 1 over 3x plus changing x raised to power 2 minus y, and that is equal to 1 over 3 into x plus changing x raised to power 2 minus 1 over, so our y is 1 over 3x squared, and the LCM of the denominator will be, let's say we have 3x plus 3x plus changing x raised to power 2, then 3x squared. So what's common here? We have 3, so nothing else is common. So we have x squared, that is here, and x plus changing x squared. So this is the LCD. So our LCD is 3x is 3x squared into x plus changing x raised to power 2. Then the first denominator in the LCD is 3 cot 3 x plus changing x squared cot changing x squared. So we have x squared remaining minus so let's say that the second denominator from the LCD, we have x plus changing x raised to power 2. So I combined the fractions, that is subtraction of fraction. So now x squared minus, so difference of 2 squared, if a plus b squared is a squared plus 2ab plus b squared, then x plus changing x will be x squared plus 2x changing x plus change in x squared whole over 3x squared x plus change in x raised to power 2 . And that is going to be equal to x squared cancel x squared, so we have minus 2x changing x plus changing x squared whole over 3x squared x plus changing x raised to power 2. And now we are finding changing y over changing x, which is equal to 1 over changing x 1 over changing x into minus 2x plus changing x squared whole over 3x squared x plus changing x raised to power 2. So changing x, cot changing x, cot changing x. Now we have minus 2x plus changing x over 3x squared x plus changing x raised to power 2 gets. So that is it. Now the next thing to do now is to find now is to find dy dx, which is equal to the limit of minus 2x plus changing x minus 2x plus changing x over 3x squared into x plus changing x plus x plus changing x raised to power 2 as changing x tends to 0. So that's our dy dx. Right? Good. So this is going to be equal to minus 2x plus changing x. Now our changing x tends to 0, and 3x squared into x plus changing x, which tends to 0 raised to power 2, and this is minus 2x over 3x squared into x squared, which is equal to minus 2x over 3x squared times x squared is equal to x raised to power 2 plus 2, which is equal to x raised to power 4. So this is x raised to power 4. So, and minus 2x, x, 1x here, cut 1x here. So we have 3x cubed, and that is going to be equal to minus 2 over 3. Sorry, no more x here because we have cut it. So if you express the fraction as a negative power, so you have x raised to power minus 3. So that will be the final answer. That will be our dy dx. That will be our dy dx. So our dy dx is minus 2 over 3 x raised to power minus 2. That is it. Thank you.